So basically, my question today is, what is good technology and how can we get there? I don't want to introduce myself so much, but I mean, there's one missing here, which is Tim Schrills. Tim has just finished his PhD, and you can download his PhD thesis. And he's also quite active in the AI domain. Actually, he brought up the topic at my lab. So he's here with us, at least in thoughts and ideas and so on. Okay, and we both work at the EMIS, which is the Institute of Multimedia and Interactive Systems, where we have 5 professors and about 40 PhDs and postdocs, have some labs and very cool, talented students in a program of media informatics, bachelor and master, and cognitive systems, a psychology master. And at my lab, we work at the intersection of computer science, design, psychology, and in the end pursue 3 lines of research, which can be mapped like such a subway plan, with a focus on integrated resource regulation of humans and technology. So we investigate both the regulation of external resources like mobility or energy and internal resources like psychological well-being and physical health. And of course, we research methods or advanced methods and theories to be able to do this. And we do this in quite a lot of very applied projects. I mean, partly fundamental science, partly applied, like ride pooling, smart charging, energy efficiency at home, and so on. And of course, also the many topics that somehow get into human AI interaction, especially in high-risk fields such as health. And always our questions are twofold. On the one hand side, what are the key challenges for human resource regulation in a certain technology context? And for the others, on the other side, how can humans be supported, optimally supported in their resource regulation, best via system design? And if you're interested to know more, then you can also check out our YouTube channel where we try to post some of our talks and other videos. Okay, so I want to start today with a fundamental question, asking what is the most fundamental thing we can say about humans when we want to answer the question of why of human behavior. And I would say that this is, in the end, quite the central or fundamental question of psychology. So why do we act, how we act? And I would say it boils down to Epicurean hedonism. So humans strive for pleasure and the avoidance of pain. But with a twist, as we all know, which is prospect theory. So of course, we hate losses and we love gains, so pleasure, but we are not completely irrational. For example, losses hurt us twice as much as gains make us feel good about that. So this is all the bounded rationality framing, heuristics, biases. And in the end, these are the most fundamental dynamics of human action, I would say. I'm very curious in the discussion if you come up with other ideas, other more fundamental or different approaches. And for every system we design, I would say we have to keep these dynamics in mind and have to take care for these dynamics. And also, and especially maybe, for systems that are more complex like AI. So I would state as a first takeaway, we should take or adopt such a volitional perspective of Epicurean hedonism calibrated via behavioral economics. But how? And so far, my research journey has taught me that the lens of resource regulation could be quite productive for this. What do I mean with that? So I would say that resource regulation in the end is a process behind Epicurean hedonism, or can be viewed, or can be a useful lens that's stated like this. And I mean, everyone knows what a resource is until one is asked to define resource, so it's a bit like emotion maybe. And the definition I like the most is a resource is anything that can be used to accomplish a plan. So in the end, to attain pleasure and avoid pain. Yeah. And I think it's quite intuitive that resource regulation from this perspective is an everyday activity, or we could even say that every one of us right now has one or two kinds of resource regulation active, or at least today. So I mean, I'm thinking of resources like energy, health, time, and I don't know, if I would ask you, I guess you would come up with a lot of more resources that are valuable right now, like fresh, cold air, oxygen in general, friends, energy to follow the talk, so mental energy or human energy. And I would say that technology is a resource too, but a bit of a more special resource. And to reiterate, for all these resources, there's the same psychological principles, which is Epicurean hedonism and behavioral economics. So if we state that technology is a resource, because I often find it a bit like confusing, I find that the most clearly way to put it is technology is a resource, or are resources that facilitate the attainment of more fundamental resources. That's the thing where it gets a bit complicated with the resource concept. Anyway, and if we use technology for our resource regulation, then we could ask, what does it mean for the core question of when does technology make us happy? So when does it facilitate the attainment of pleasure and the avoidance of pain? So what is good technology? And I would say that happiness in the end boils down, so at least I would assume that most currently would state this as fulfilling fundamental human needs. So self-determination et al. Perspective on basic human needs like autonomy, competence, relatedness, or self-esteem, where we could doubt if it's a basic human need, or, you probably know the paper of Sheldon et al. who worked on this. And then in the end, you could say that the needs are the tools that we use, or they serve Epicurean hedonism. So if we design technology to serve basic human needs, it should make us happy, but as we probably also are aware of, there's quite a risk, which is addictive tech. Because if you have a very optimal design technology that has an instant satisfaction of human needs, it can be quite addictive, more addictive than, let's say, non-technology alternatives for like spending the next hour. Yep. And now there's another important thing, which is that resource regulation is a process, or we should best view it as a continuous process. So it's not so much, or not best described from my perspective at least, as in behavioral economics experiment, where you often have discrete choices, but in the end it's a regulation of resources that is continuously happening and overlapping also several processes of resource regulation. And then the next thing that I really like about the resource regulation perspective is that it's not just a cognitive perspective, as it is often in engineering psychology, but it's also a motivational perspective. And when we go for motivation, we are also close to emotion and other affective states. And the core question that emerges from this is, how does this dynamic process work? I would say we can conceptualize this resource regulation process as a continuous feedback control loop. And I don't know if some of you are familiar with this loop design. Anyone saw this already? Okay, so I can perhaps say a few words more. So in the end, this is a perspective that you have from cybernetics, or from control theories, from engineering, or from Carver and Shire's self-regulation theories that is referenced here, but it's also implicitly there in many other psychological models, like the stress model of Lazarus or Folkman. And the basic tenet is that humans strive for, as we know, pleasure and not pain. And we do this by having certain goals or references. Let's make a pointer here. Goals and references, and we have input functions, how we set our perspective on our environment, and we compare input function and goal reference and adopt output functions to regulate the discrepancies that we perceive. So to understand resource regulation, in the end, we have to understand or model, let's start with modeling, these single components or modules of this very basic self-regulation loop. So there's cognition about how we structure the input function or the goals, how we represent our goals. There's motivation, of course, like all the goal-setting dynamics. And there's emotion as a epiphenomenon, or maybe also more than just this. So there are affective outcomes of certain comparator states, for example. So let's apply this to a very basic and intuitive case of human technology interaction. Let's say you're on your long distance journey with your electric vehicle, Italy in the summer, I don't know. And maybe you're a bit lazy with charging, because why should you? So quite likely you want to avoid the pain of getting stranded with an empty battery. And your remaining charge is your main resource to avoid this pain. So a key resource. Now, typically you have plenty of fast charging opportunities, so you may consequently decide to wait until it's really necessary to charge. So your available range buffer is below the comfortable range. So let's say you have 200 kilometers to drive, 150 kilometers range. So it would be quite comfortable to not charge en route and now change this configuration with smaller and smaller buffers until you would say, okay, I charge half route or else. And mostly you will monitor and regulate your factors like the maximum speed you take in the end, avoid excessive range losses. And if somehow your coping processes are not optimal or fail, or there's a discrepancy or a variation in the environment, then maybe you start some eco-driving to extend your range, or you choose an earlier coping opportunity. And only if all these mechanisms change, these action regulation mechanisms fail, then range stress could occur. So this basically says that what we also found in studies already a long time ago, that people typically, when they drive the electric vehicles, they will not or very seldomly actually experience range stress after some time of adaptation. It's more the avoidance of range stress, and people may even not find it very logical to relate to the phenomenon of range stress, but maybe say more of, yeah, it's a range management task. I just drive like I need my range. It's a very natural and not very stressful action regulation, resource regulation process that's happening there. And of course, nowadays, you have better and better agents that support you in this range management and give you all the information you need, and maybe you have a full automation of where you have to charge. But then the interesting question is this integrated with your information processing and motivation or not? But we'll come to that. So I would argue here that a cybernetic perspective of action regulation can help us to structure human resource regulation in human technology context. Now, where it gets interesting is when we have increasingly intelligent systems. So a resource regulation together with other humans or together with technology that is not as intelligent as humans, but has some features that we would name currently, at least when we are in a buzzword state, intelligent. And I think the interesting question is when these systems themselves have some kind of control loop design. So they have targets that are pre-programmed, they follow certain reference functions based on these targets and goals. They have certain input functions, sensors to integrate lots of information, and they have certain output functions to act on the world, maybe also with quite a big degree of autonomy. And the question is now, when we have two agents that are more or less working on the same problem, we have the classical questions of how do we share the task, and then we have more of a question of how do we communicate. The more autonomous this agent, the technical agent is, how do we communicate best between both? Or we would rather say, where should we best couple these two regulation, action regulation processes? And as a side note, I think it's very interesting to work from this action regulation perspective when we design and research technology, because people from control engineering, which are typically the ones who have all these optimization problems and optimization approaches, for them it's a natural language. So they have very similar models, which we'll maybe see if we decide for this next chapter, some slides after. So we have two action regulation loops. How can we make them become one? So first I would say we have two entities. They perform actions, have similar goals, and work in the same ecosystem. It's quite likely there's some kind of interaction. And the interesting thing is that when we are in human technology interaction, we probably use the term interaction quite a lot, but I'm not sure how many people can define what interaction is. At least it took until 2017 before there was a paper that I like quite a lot. Of course, still, there could be lots of improvement, but it tries to condense all the perspectives that are prevalent on interaction in the HDI community. And we today would say that as soon as there's some kind of bidirectional transmission, so exchange of energy or information, so be it light, sound, or kinetic patterns, there's some coupling, so to say, interaction. Today we will especially look for aspects of dialogue, transmission, and very much control, as this is our perspective here. And the question next arises, of course, what is then the quality of interaction? So how can we specify and maybe also quantify the quality of this coupling? So first question could be, where do we borrow such quality criteria? Of course, people typically borrow it from what they know, so human-human relations. So of course you can ask, does technology serve my immediate goals? So there we have usability. Does it serve my underlying needs? There we have typically what we frame as user experience. And then there's the next question, which is slowly evolving and getting some structure in the research from my perspective, which is, can we act together? So can we create a deeper connection, a kind of coupling from being a couple or a relationship with more relationship strength? And I would say these are certain vectors. First, from a tell-and-do communication style to interdependence, an interdependence interaction paradigm. A co-active joint action from a cross-pole perspective could be seen as control, like a co-regulation. I will come to that in a second. And then you could say there's a continuum of coupling strength or depth, which is coordination, cooperation, collaboration. I would suggest in the end it's integration. Some models say there's teaming, but I think personally I don't find it very coherent to say teaming here in the end, because I would say it's more integration, it's more of a natural follow-up. And it's important to think about it because if we look in the literature, that's a paper from a similar set of authors from 2019, when they look in the literature from Chi, from 35 years of Chi, they find a lot of interaction quality modifiers, but typically they are not very, they don't go very deep. Of course, there are some works that are important to name here, like the co-active design framework, which is focused on the co-regulation, not co-regulation, on the, in the end, coordinated actions of two agents, or the joint activity framework, which looks for what does it need for effective coordination in human technology teams, and some other interdependency theory from social psychology, which is the basis for this or fundament for this. And I would say that based on this, a next step would be to adopt the perspective of co-regulation. So if we have regulation, we have two loops, then the question is how can we design effective co-regulation. So co-regulation can also be bad, right? If you and your partner co-regulate and you do it in a very bad way, then you can also make it worse when you're in a fight or a colleague or who else. So I would say co-regulation to start with is a bidirectional coupling of two or more self-regulation systems, self-regulating systems that dynamically adapt their resource regulation in response to each other, enabling the emergence of a stable integrated regulation dynamics in an interdependence paradigm. If you would have a lot of time, I would like to speak a lot about these ideas, but maybe we can come back to this in the discussion. For now, I would say that's more or less a starting point for what I promised in the abstract, this adaptive co-regulation of resources and actions framework. And if we say this is our basic idea of how we frame the interaction, then this could be a takeaway. So this co-regulation perspective could help us structure this integrated resource regulation of human and machine agents. I leave this out, maybe for the discussion, because there's a very interesting twist here. But then, of course, the question is, how can we best integrate human and machine agency? So it's again about these quality indicators. And here, there's not too much of scales and indicators already on the market. Because, I mean, of course, we always need some kind of performance. So in the end, we design for the joint performance in the short and long term. But if we speak of action regulation, we have to see that action regulation is centrally driven to by what humans perceive, target, and act on. So we have to target, in the end, in the assessment, their experienced internal states and also facets of user diversity. Some scales we have developed over the last years are, for example, the subjective information processing awareness scale. So am I enabled by, for example, an AI agent to perceive, understand, and predict how an intelligent system processes information? And second, the perceived cooperativity scale for AI agents, or we also adopted for human-human interaction. So the subjective perception of the ability and willingness of an agent, so a co-agent, to contribute to a joint activity. And there are more. There's also one from the group of Martin Baumann, which I like quite a lot, the Human-Machine Interaction Interdependence Questionnaire from the dissertation of Marcel Beude. And probably there are more, maybe if I'm not aware and you have ideas, I'm very thankful. So these are scales. And of course, as I said, user diversity also makes a big impact because people will have quite a diverse set of variation. And of course, to systematically understand this kind of variation, we need scales like maybe affinity for knowledge interaction, need for cognition, but maybe also something like attachment styles. Because if we say we have relationships with certain kinds of AI tech, then it could also be that attachment styles could help us explain how people differentially approach these. And also things like propensity of experience of permission, shame, but we can go to this in the discussion. So that's what I promised, a fast introduction. And looking at the time, I would say for now, thanks for your attention.